And hello, my wonderful AP students. Joe Ockman's here to kind of walk you through how I want you to think about these homeworks. So please have it out and let's make sure if you're right or not. First question. Two balls are launched horizontally from top of the building. Okay, so you're putting them both straight forward. The lower velocity one hits the ground first. And the answer, absolutely false. From the point of view of both balls, they have different x velocities, but their y velocity are both 0. They're both going to fall the same distance because they both started from the same building. They both have the same acceleration. Both initial velocity of 0, both same acceleration, -10, both same meters to fall. They will hit the exact same time, just with different velocities. This is asking for a time. Number 2, or the second one. Two projectiles launch at the same speed but different angles. They must always hit at different distances. And that is also false. If it's a level ground, so the initial and final y points are 0, we know that complementary angles always hit at the exact same point. And as evidence here, here's a shot at 30 degrees and a shot at 60 degrees with the exact same initial velocity. If this is the starting position, at the same ending position, they always hit at the exact same place. What is the only angle not to have a complementary angle, or its complement with itself, and that is 45, and that will always get you the farthest distance on level ground. If it's not level ground, then you might actually have some differences there. And now for I think the toughest one of them all, number 2, the real number 2. You shoot something off at 5 meters per second at 40 degrees. Which of those paths is appropriate for the situation, 1, 2, or 3? All we know it starts 5 meters above the ground, and we're looking 5 meters away. So, how I want you to approach this. Your first thought is, I don't really know what 5 meters per second at 40 degrees is, but we have two distances, one in the y, one in the x. Let's find the x and y parts of this initial velocity. For the x, which is this part right here, if you drew a picture, which you should have, you would eventually find it to be 5 cosine 40, which in degree mode is around 3.8 meters per second. Do the same for the y. When you've drawn the triangle, the y is going to be the opposite, that means sine. You're going to find the y part of this 5 is 5 sine 40, which is 3.2 meters per second positive. It's going up. Okay, so how does that help you? Here's how I want you to think. Which one is the easiest math, vertical or horizontal? The answer is, because of the lack of gravity, horizontal. So it's going 3.8 meters per second forward, and it's got 5 meters to cover. How many seconds will it take? Well, if it has to go 5 meters and it's around 3.8 meters per second, it's between 1 and 2 seconds. The actual number is something, but right now we're just kind of don't have to worry about that. Okay, so between 1 and 2 seconds. Let's find the y velocity after 1 or 2 seconds. So it's going 3.2 meters per second. After 1 second, it's lost 10. It's now going some negative value. And the negative value is very big compared to 3.2. So since it has a negative value, it is already going down. So automatically 1 and 2 are out of it, because 1 says it's still kind of going up. 2 says it's kind of got a velocity of 0 at the y point. So what about 3? Well, it's already at a negative value that's larger than 3.2. So that means it's below where it started. Because remember, if it started here with the upward 3.2, then right here, the exact same point, it's going to go down at 3.2. But it's already beyond that. So it's somewhere down here. So to summarize it, after that 1 second, it's already kind of below where it started. And since it's between 1 and 2 seconds to get up here, it's going to be somewhere down in this region. So obviously it can't be any one of the paths. And the answer is D. Another way to think about it would somehow be to calculate, based on this, the displacement using that time in the y. Find y final. You find it to be some very negative value, which means after 5 meters it will be down below. That's why I want you to quickly grasp the situation, just analyze it, and don't get bogged down in the mathematics. The third question also looks kind of tough. You shoot a potato gun at 99 meters per second at 30 degrees. What speed will it hit the ground at? Obviously not 0, because it hits with some velocity. Looks difficult, but wait. If it starts at 99 meters per second at the exact same point on the same level ground, it will hit at the exact same velocity, 99 meters per second. So it's going to hit 99 meters per second at a downward angle of 30. Cool, that was easy. No math involved. Dang. And finally, this one. You fire a projectile, and there are 3 points, A, B, and C. Notice how C is the lowest, A is middle, B is high. Question A, what is true about the speeds of the ball? Well, once again, if this is the starting velocity, it has the exact same velocity, the exact same height on the other side. As it's going up, the x velocity is constant, but y is changing. As it's going up, the y velocity is decreasing. So in other words, as it's getting up and up and up, its overall velocity getting lower and lower and lower, with a minimum at point B. So E shows that the lower you are above the point, the faster you're going. What is the x velocity the least? Well, they're all equal. We said that. They all have the same x velocity because there's no acceleration, because gravity only pulls you down. Where is the magnitude, or just the amount, of the y velocity the least? Well, at the top. At the top, it's not moving up or down for that moment. So B. And with that, my wonderful students, this should now be a little bit better to understand and apply. If you have questions about this, let me know in class next time I see you, because it's not the last time you're going to have to think about these kind of situations without doing a gigantic amount of math. Goodbye.